Okay, last practical application question we've got here, and it's kind of a neat one because it really deals with something that kind of hits home for me, car insurance. Yeah, and the costs of car insurance. And it says here, the cost of car insurance depends upon many factors, one of which is age. So we're talking age in this particular question, age of the driver. So if you think about this, if I'm going to make a graph here and I'm going to put age down here, think about what ages we're talking about. We can talk all the way from an infant over here, which of course, gosh, we don't want the infant to drive, please, all the way up to an age of, let's say, about 100, because right around there is, they're getting kind of old and not too many people live to 100, so we know we're going to have a graph that looks like this. Insurance companies also know that younger drivers under the age of 25 and older drivers over the age of 70 are statistically more likely to have more accidents. Okay, so here's your age of 25, let's say somewhere around here. Here's our age of 70, which is somewhere around here. You know that their accident rates are going to be quite high. They're going to be up here, and this guy's going to be up here. And look what that's forming. That's forming a wonderful little parabola. So there's statistically an age here, a minimum number of accidents is going to be somewhere right around there. Wonder what that's going to be. Interesting. It says the following data shows the number of accidents per million kilometers driven by drivers of a particular age. Okay. Well, wait a second. We can graph this. Let's sketch this out. Let's see what we get here. So if I've got my nice little graph right here, I can see that, all right, age is going to be over here. Okay. The number of accidents is going to be over here. And I think I already noticed the trend, but I want to show you something. There's 18 right here at about 5.2. So look, we got 5.2, 3.1, 2.2, 2.8, 4.7. Okay, so all right, here we go. From 5.5, which is 1, 2, 3, 4, 5.5, which is about here, to the next one, which is the age of 30, so there's the 18, there's the age of 30, which we say is now 3.1, so 1, 2, 3.1, which would probably be around here, to the age of 45, which looks like it's the lowest. So 45, I'd say, is about here, which looks like the lowest at about 2.2, which is about here, okay? Now we're getting up to 60, so we're making a pretty big jump over here to 60. Okay, and we're back up to about 2.8, so 2.8, which is about here, and then 75, which is back up to about 4.7. So you, in fact, can see the nice parabolic trend right there. Perfect. So it is a parabola with some kind of minimum value, and that looks like it's around 45. Now you may ask yourself, and when you go to class here, ask me the question, why do you think it's around 45 years old, which has the fewest number of accidents? Let's talk about that as a class. So make sure you raise that question up in class. All right, so look at this. It says it has been determined that the equation models this ugly. Oh my goodness, look how terrible this looks. Here's the equation for it. Yuck. Oh my goodness. Now, could you imagine not using your calculator for that? I couldn't. It says use the formula to determine what age to the nearest year results in the lowest number of accidents. Ah, okay. So we're trying to find the minimum value. What age, right? And what year does this happen in? Okay, so let's graph this thing right now. So here's my calculator, all Zoom standard, ready to go. Let's put in the equation of y equals 2. So what I'm going to do here is I'm going to get rid of this big ugly screen here so I can see the screen below it. So I can see the equation below it, I should say. So here's the y equals 2. Let's plot that in there. That's 0.0034x squared, oh my goodness, minus 0.3232x, 0.3232x plus 9.8505. Okay, there's our graph. Now, if we hit graph, I'm going to tell you right off the bat, you're not going to see a whole heck of a lot. Okay, think about this. We're talking about age. And if we're talking about age here, we're going again from 0 out to about 100. So there's our x value. We're going from 0 to about 100. So let's go into our graph here and let's change our window. Our window has to be from about 0 to about 100 years old. Okay, let's graph that and let's see what we've got. Oh, beautiful. Now, do I actually want to go up by ones? If you looked over here, back on this graph over here, I went up by, well, looked like I went up by 15s for a while there. So you know what? I'm going to go over here. I'm going to go back into my window setting, and I'm going to change my X scale, not to go up by ones, because that's kind of ridiculous. Let's maybe go up by 5 increments, okay? And if we do that, I think that's going to be really pretty. Let's look at the graph. Okay, beautiful. Also, another thing that I want to point out to you, do we really need negative values here? We really don't. So we can change the Y now. Let's change the Y table here. So window, let's go into the Y values. Let me erase this because you can barely see it. Okay, let's go into the Y values here, the Y minimum. Let's get rid of that. Okay, because let's bring it up to 0 accidents. How can you have negative 10 accidents? It's impossible. Now, let's see what this graph looks like now. Oh, much prettier. Look at that. Now, here we go. Let's calculate now the minimum. Second calc minimum, which is 3. Okay, left bound, so we're on the left side of this. Here we go. Okay, enter. Let's figure out the right side. Here we go. Enter. And guess, and you're going to see that the minimum accidents are at 47.5 years, and you're going to get 2.16. And if you can't see that very well, I'll make this a little bit bigger here so you can actually see it. 47.5 years old, you're going to have 2.17 accidents on the average. So 47.5. So 47.5, okay, years old. Okay, they're going to have the minimum number of accidents, and the minimum number will be approximately 2.17 accidents. 2.17 accidents. Okay, is what the insurance company is predicting. Does that actually happen? No, because of course it's a prediction. Some people can go their entire driving lives without having a single accident. Others could go have 2, 3, 4 accidents. Who knows? That's one of the reasons why we buy insurance, and this is a predictor. So based on this model, who is more likely to have an accident? A 17-year-old or a 78-year-old? Now think about this. When we graphed this, remember, we had this to be age. So here's our 17-year-old and here's our 78-year-old. Let's figure out something. How do we figure out values of X equals 2? Well, I just gave it away. How do we figure out values of X equals 2? We go to the calculator and hit value of 16 and 78. Let's figure it out. Value, second calc, find me the value, which is the first thing. Here's a 17-year-old. Let's figure out what the value is. The value is he's going to have 5.33. Now, kind of memorize that. Okay, 5.33. Now, let's go and figure out our 78-year-old. Second calc, find the value of a 78-year-old, and check this out, 5.33. They're both going to have about the same number of accidents. So a 17-year-old and a 78-year-old are most likely to have accidents. And that's one of the reasons why your insurance rates are way up there, especially if you're a young person trying to buy a car for the first time. You're going to pay high insurance rates. That's how it works.